techniques. Here, analytical techniques are also known as instrumental methods or analytical instrumentation, right? So, instrumental methods means the analytical methods, and this analytical methods means the methods which are used for the analysis of the substances. So here the point came is what we understood by the analysis of the substance, right? So here, as you can see, SEM is there, NMR is there, right? So likewise we will study about NMR spectroscopy, scanning electron microscope, transmission electron microscope, what is the meaning of mass spectrometry, what you understand by EDXRF. All these techniques are known as a very sophisticated hyphenated methods, and they will give us a pure substance and even a combined substance or a mixture of compounds results very precisely. That means the results are considered as final when we deal with such kind of instrumentation methods, right? So after doing the preliminary examination or chemical examination of any substance, we will came to the point that where we have to understood that what is the actual structure, what is the actual composition of our material. So here we will go through that, right? So the first word that came into our mind is analysis, and what we understood by that. So to know or to understand any particular substance is known as analysis, right? Analysis can be of two types. First one is qualitative, second one is quantitative. Okay, so two words are there. First one is qualitative. Now as you can understand, qualitative means to analyze the qualities, to analyze the properties, right? So in the first one, we will identify the sample, while in another one, which is a quantitative analysis. What do you understand by that? So quantitative analysis means we will find the amount of compound which is present in the particular solution or in the particular mixture. Both the things are different. One will identify the property, another one will identify the amount. Okay? So, the instrumental methods are the methods for measurement of the physical properties of the substance, like its conductivity, its pH, its electrode potential, its absorption phenomenon or its emission phenomenon, even its absorption frequency, emission frequency, etc., its mass to charge ratio and fluorescence. Let's begin to employ for quantitative analysis of inorganic, organic and biochemical analysis. Generally, all this method involves both the kinds of analysis, whether it's a qualitative or whether it's a quantitative. Right? Now, let's begin with our first one, which is NMR spectroscopy. Here, the full form of NMR is nuclear magnetic resonance spectroscopy. Right? Now, as you can see here, the word itself contains two different things. Number one, nuclear. Number two, magnetic. Okay? So, it is related with the nucleus of the substance, along with or in the presence of magnetic field. So which kind of resonance will occur in a nucleus under the influence of magnetic field will be studied in NMR. Okay, so nuclear magnetic resonance spectroscopy is a powerful analytical technique used to characterize organic molecules by identifying carbon-hydrogen frameworks within the molecules, right? You can see here the instrument which is known as NMR instrument. It is used and it is available in various sizes. Depending upon the size of the magnet, the size of instrument changes. So here what we will have is two common types of NMR are generally used. Number one, which is carbon NMR, or I should say carbon-13 NMR, while the second one is 1H NMR. As we have seen earlier that it generally identifies the carbon-hydrogen framework. So it involves the identification of these two particular molecules. Number one, which involves hydrogen. So it determines the type of hydrogen which is present in the particular compound. While the second one, it involves carbon-13 NMR, right? So here we will identify the number or the type of carbon isotope which is present in particular compound. Okay? So let's understand its principle, that how and why it is used. So it is a research technique that exploits the magnetic properties of certain atomic nuclei. It determines the physical and chemical properties of the atoms or the molecules in which they are contained. So it is basically related with the nucleus of the atom, which contains two different things. Number one, proton. Number two, neutrons. Now let's observe its principle. So here, as you can see, first one, a spinning proton creates a magnetic field. We all know that the proton generally spins on its own axis. So at that time, the spinning causes a magnetic field, right? Now, when no other magnetic field is present, any extra or external magnetic field is not present, they are oriented in their own axis or they are indisciplined in manner. Now, when we put them under the influence of a particular magnetic field, let's say for an example B or B0, at that time some of the protons orients with the direction of the magnetic field, while some of the protons orients against the direction of the magnetic field, and depending upon that their identification is done, right? So this is the principle of NMR spectroscopy, basically how we identify a particular atom. Okay, now in next one we will have instrumentation and working. Now as you can see it here, a huge magnet will be taken, a strong magnet is taken. In that we have our sample tube. That particular sample tube is rounded or coiled by RF or RF transmitter. So RF coils are just only wrapped on the sample tubes, right? So it is RF transmitter, along with that the detector is there, along with it contains magnetic controller. So we can control the magnetic field as well as we can control the radio frequency also, right? So all this finally gives us the absorption of the frequency. Here in general we have to understand that in industry what we will have is a sample, right? So both liquid and solid types of samples can be used in NMR spectroscopy. The sample is generally dissolved in a solvent like CdCl3 and placed under the influence of magnetic field. Now a radio frequency generator then irradiates the sample with the radio frequency, right? Now what it will cause? It will cause the resonance. How? So in general, in industry, what we will have is, we generally have the magnetic field as a constant one while we change the radio frequency, so that the proton will resonate from its lower energy level or ground level to the excited level, and at that time it absorbs the particular radio frequency. That gives us the identification of a particular compound. Okay. Now modern NMR spectrometers contains, like as I said, a constant magnetic field and a fluctuating frequency, right? Only nuclei that contain odd mass numbers or odd atomic numbers give rise to the NMR signals. For example, 1H, carbon 13, 19 fluorine and 31P. Now here two others are there like 2H and 14 nitrogen that will not give us any kind of resonance, right? So here chemical shift, one word is there, the relative energy of resonance of a particular nucleus resulting from its local environment is known as chemical shift. Here, each and every compound has its own chemical environment and because of it, such kind of behavior is observed, right? Now, applications. So, nuclear magnetic resonance spectroscopy provides the detailed information about structure, dynamics, reaction states and chemical environment of the molecule. As well as it has various applications in food industry, food science laboratories, chemical analysis of different products and pharmaceutical approaches also, right? It is also used to analyze the carbon-hydrogen framework. So I can say that when we have a pure substance or a new molecule find out in chemistry or in any other branch, it can be identified using NMR. This is all about this session. Next we will learn in our next session. Thank you everyone.